Hey there, ladies and gentlemen. Today we're going to be solving systems of inequalities. It's very similar to equations, except obviously we have some shading involved. So the definition of a system of linear inequalities would be that we have two or more linear inequalities. On the same coordinate plane, or on this, I'm just going to put plane. So basically we're graphing them at the same time. All right, so when we are going to graph a system, the first thing we need to do is solve for y, because remember we need the m and we need the b in order to graph that line. So then in order to do that, we're going to graph using the m and the b. Remember, m is slope, b is y-intercept. And then we go through that same process. Are the lines solid or dashed or dotted, I guess, whichever word we're going to use. And then we're going to shade just like we did before. Now, because we have two of them, then we're going to actually repeat this process again. So we're going to do it twice, but on the same coordinate. So our solution is located where the shaded region overlaps. So let's look at let's see what this looks like. So if you notice here, we have two inequalities that are already solved for y. So I'm actually going to graph these. So I'm going to start with the first one. I have an m of 2 and a b of 1. So I'm going to go where my y-intercept is at 1, and I have a slope of 2. Obviously, you can use Desmos. I'm just doing it by hand because I love the challenge. And of course, this line is a solid line because it has an equal sign. So there's that. And then it says y values that are greater than or equal to. So then I'm going to shade above that line. So now let me switch to a different color, and now I'm going to graph the other. So I have an m of -3/2 and a b of 4. So I'm going to start with my y-intercept at 1, 2, 3, 4. And a slope of -3/2. So I'm going to go up 3, 1, 2, 3, left 2, up 3, left 2, and so on and so forth. Okay, sorry, I thought I went too far on that one. And there we go. This time it is a dashed line, so I'm just going to throw some dashes in between those dots, and our arrows continue this way. This time y is less than or equal, so I'm going to be shading below. So here is my shading, and you can see where the graph is double shaded. The double shaded region is where our solutions are. So from here, I can essentially ask you if we have, if a certain point is a solution. So if I asked you if, I don't know, let's say -2, 1 was a solution, you would go to your origin, you go -2, 1. That point is here, so this would be a yes. But then at the same time, if the point is actually on, I don't know, let's say, we could even pick this one. This one is 2, 1. This one would not be a solution because it is not in the double shaded region, and it is even on a dotted line. So keep in mind how all of that actually works for us. So let me add Desmos here. All right, so let's go ahead and graph these. So we have y is less than or equal to -x minus 3. So there's our first one. And now let me graph the next one. So we have y is less than 2x plus 1. So you can see now the double shaded region is our solution. Now I want to show you something. Let's say that I am going to just change this. Let me just change this here. to a negative x. And I'm going to also change this sign. I'm sorry. I'm trying to get creative here, and it's... So let's say I have this. Is there a double shaded region? If there is no double shaded region, then in this case, there would be no solution because it doesn't overlap at all. So see, it's just like when we graph lines. If the shading doesn't overlap or if the lines don't intersect, then there is no solution. All right, let's try this one. So we have y is less than or equal to negative 3/4. Oops, it would help if the divide symbol would work. X plus 1. So there's our first one. Let me go ahead and graph the other. The good thing is with this, you do not have to rewrite it. So this brought me back to what I was just talking about. As you can see here, this would be a no solution because there is no overlap, because that goes that way and that goes that way.